Okay, so I welcome you guys back to our managerial economics tutorials question. Finally, we are back to solving our first question. That's the regression model, what we call the demand demand estimation. Yeah, demand estimation, where we deal with the regression analysis. So with the question one, let me pin the question. So question one. The marketing department of a very popular beverage company is seeking to determine the factors that are very influential in triggering demand for its products. That's Mike Pizza. To this end, the department employs the services of an economist to estimate its demand function. The economist determined that Mike Pizza was influenced by its own price, the income of the consumers, the amount spent on advertising, the price of Sprite, and the price of Max Pizza. The economist that seeks to estimate the model. So you have QDX is equal to beta naught plus beta 1 px plus beta 2m plus beta 3 advert plus beta 4 ps plus beta 5 pm plus e. The e is what we term in regression analysis as an error term. So we have summary output here. We have the ANOVA table as well. The ANOVA is what we call the analysis of variance. Then we have this table as well. So we have three tables in all. So let's go back to the question. Okay. So the A part of the question states that write out the estimated demand model. Now, I would like to emphasize on something at this particular point. Whenever you're asked to find or write down the estimated demand model, people end up using this particular one, the one given in the question. That's one. And they just fix in the numbers into it. That is a big mistake. Sometimes this estimated demand equation given to you can be correct. If it's correct, then we use it to solve what our question. But sometimes they can give the estimated demand equation to be wrong. So in that instance, if you are able to use that same thing to solve the question, you get everything wrong. So what you have to do is you would have to learn how to form an estimated demand equation when you are given a regression question. You should learn how to form it. So once you form it and it's similar or is the same as what was given to you in the question, then it means you can just continue straight away with the question. So for instance, with this particular question like this, there was a mistake with, let me not say it's a mistake, it's a question that has been given, but they intentionally or mistakenly made the question, the regression equation wrong. So if you don't know how to form a regression model, it means that you won't be able to solve this particular question. So let's start. So I will show you what I'm trying to talk about. You see, this was the equation given to us. We would form ours. Then we'll come and compare our regression model to this equation that was given to us in the question. And let's see if it will be the same thing. So this is, so QDX stands for quantity demanded for Mike's Pizza. Then PX is price of Mike's Pizza. M is consumers income. ADV is advertising. PS is price of Sprite. PM is price of Max Pizza. Okay. So now we start. So I'm starting with the first question, which is the A. Estimated demand model. That's the A part of the question. So with the estimated demand model, now in the question it was stated that we were given QDX. So let me use it. Quantity demanded. This is QDX. So now we are about to form our equation. Now we always start with a beta naught. Now this beta naught in the question, they wouldn't state beta naught in it, but in the question you will see constant or intercept in the question. Once you see constant or intercept, it's the same as beta naught. It means where we see beta naught, we will fix the constant on the intercept with value. Then the next thing we'll do is you will come to the question. So the beta naught, there's no beta naught, but they've written intercept. I told you it's intercept or constant. So it means why I see beta naught, I'll fix 33721.01476. That's the beta naught. Then the next thing we'll do is you will pick the next coefficient here. So the next coefficient is negative 260.6819889. Once you pick this coefficient, then you join the variable to it. So it becomes minus 260.6819889 px. You pick the next coefficient, minus 4.99278412 m. It follows in that order. So before we start that, we have to form the equation. So the number of items here determines the number of betas we are supposed to use. So we have px. So 1, 2, 3, 4, 5. It means I'm going to have beta naught. I have plus beta 1 px plus beta 2 m plus beta 3 advert plus beta 4 ps plus beta 5 pm. Now you notice that I didn't bring the error term. When you are forming the actual regression equation, we don't need the error term. So now let's start. Now the betas you see here, the betas, these ones, the px, m, advert, ps, those are the independent variables. So this is our dependent variable. I'm using it to explain the topic itself. So dependent variable. So now the beta 1, beta 2, beta 3, beta 4, beta 5, they are the coefficients, or what we call the parameter estimate. Now with the, where do I even put it? With the px, the n, the advert, the ps, and that of the pn, they are the independent variables. Now, so I've just given you an overview of this topic. QDS is dependent. Beta naught, always the first one is beta naught. That's what we call constant or intercept. Then the beta 1, beta 2, they are the coefficients. Then the independent variables are the px, the m, the adverts, the ps, and the pn. So now since we have an overview here, let's form it. So I'm forming the equation. So this is QDX. So the first one is beta naught. I know it's constant or intercept. I'll come to the question. There's it. Intercept. Constant or what? Intercept. So it's what? 3, 3, 3, 3, 721.01476. You can shorten the numbers. After the point, you can pick 2 or 3, but I prefer I use the same thing in the question to solve it. So there's the beta naught. The next thing we do is you would pick this number, join the variable. So the next coefficient is negative. So minus 260.19889. Then the variable that is in line with, you join that variable. So the variable in line with is what? Px. Then I'll pick the next coefficient, minus 4.992784128. Then it matches with which variable? M. So you join the M to it. Then the next coefficient is plus 7.20. Let me continue here. 2046804443. Which variable is it matching to from the side? So you could say it here is what? Advert. So that is advert, ADV. Then the next coefficient is minus 4465.535308. Then we join the variable. Which variable is that? Px. This is Px. Plus the next coefficient here is 112.6920.947. Which variable? Pn. So this is the A part of the question. Estimated demand equation or estimated demand model. This is it. Yes. So now, what I was saying that sometimes the equation given can be wrong. Let me cross check it here for you to see. Let me move it now. Now you see the beta naught. This is our beta naught. Okay. Now, in the equation, they both positive, but in our equation is what? Negative, because in our equation is negative because the number here, the coefficient here was given as negative, but in the question, they did it what? Positive. The next symbol here is what? Positive. But the numbers given to us was what? Negative. That's what I'm saying, that always form the equation yourself. Don't follow the sample given to you. Form it yourself. Like the way I was able to form it here, then you'll be fine. So that's the A part of the question. I move to the B part of the question. So the B is interprets the coefficient of the estimated. So interpretation of coefficient. So the interpretation of coefficient. So we don't mostly we have the beta naught, but we don't mostly interpret it. Yes. So we start from beta. So we start from the first variable px. So with px, we'll check the coefficient. This px, the coefficient of px is minus 260.6819.889. So we interpret it. So this is how the interpretations as a format. A unit increase. A unit increase in px will lead to a unit decrease in qdx by 260.6819.889. 889 units, all things being equal. So I'm done with the interpretation for PA. So now let me explain. A unit increase in PA, which is the independent variable here. Remember, I made mention of it from the top. Those that are independent variables. That's here. You can check it from that side. So a unit increase. We always start with the statement. Take note here. Please watch it very well. We always start with the statement. A unit increase in PX will lead to a unit decrease. Will lead to a unit decrease in QDX. Now, it's always the side that changes. A unit decrease, the side. Now, if the number given to you, if it's negative, this sign here, this one. If it's negative, this side, you put decrease. If it's positive, so negative is decrease. I'm taking my time to explain it well. If it's positive, then it's increase. It only applies to this side, but we always start with this statement. Whether it's negative here or it's positive, we always start with a unit increase. But the negative and the positive depends on this side. This side. So assuming this number was positive 260, I would have written a unit increase. But since it was negative, that's why this side I wrote what a unit decrease. Then it follows in that order. So you notice that with this number I wrote here, I didn't bring the negative. So one would ask, why didn't I bring the negative back? I didn't bring the negative here again because of the statements that was used here, a unit decrease. So you don't bring the negative, you just bring the number and attach what? Unit to it. So that's all for the first variable, px. So the rest I'll just write it down for you guys. I'll explain it. So the next variable is m. So m is minus 4.992784,128. So we start. A unit increase in m will lead to a unit decrease. I'm using a unit decrease because it's what? It's negative in QDX by 4.992784,128 units, all things being equal. So I'm done with the M. The next item here is what? Advert. So the advert is also 7.20468043. So remember I stated that it always starts with a unit increase. So a unit increase in advert will lead to a unit increase. This side is a unit increase because it's what? Positive. A unit increase in QDX by 7.204680,443 units, all things being equal. Then the next item is what? PS. So this was income. This was for adverts. Let me underline it so that you know the ones we've done so far. This one was for PX. So adverts. The next one is PS. So PS is minus 4465.535308. So a unit increase in PS will lead to a unit decrease in QDX. Will lead to any decrease in QDX by 4465.535308 units, all things being equal. So we move to the next variable, PM. One 2.6920.947. So a unit increase in PM will lead to a unit let me will lead to a unit increase in QDX by 112.6920.947 units, all things being equal. Okay, so let's go back to the question. Okay, so the next day, so I've done the A and the B. The C is interpret the adjusted R squared. So that's what C. C interpret the adjusted R squared. Okay. So with the adjusted R squared, when we come to the question, it was given this is it, adjusted R squared from the side. So it's 0.994, sorry, it's not 994, 0.993 83841. Yes, so there's it. Adjusted R squared. So we're asked to interpret it. So let me enlarge it and explain it. So this is how we interpret it. An adjusted R squared of of 0.993 let me claim it. An adjusted R squared of 0.9938471 implies that all the independent variables all the independent variables all the independent variables explains about, then the number here multiply it by 100. That's so about 99.38% of variation in the dependent of in the dependent variable. My pen is disturbing a bit. I hope you guys will manage it for me. So an adjusted R squared of 0.993838471 implies that all the independent variables explains about 99.38% of variation in the dependent variable. So that's the C part of the question. So we continue with the D part of the question. So the D, if Px is equal to, so let me write it here before I switch the screen. So with the D, if Px, they give us Px px 15, m is 10,000, advert is 1,000, px is equal to 2, and pm is equal to 25. So if px is 15, m is 10,000, advert is 1,000 cedis, px is 2, pm is 25. Determine how many units of Mike pizza will be bought. So it means you're actually finding for quantity. So we'll just come and pick this demand function here. This one. We will pick this particular one, this demand function, to that point. So we'll pick the whole of this to the D part of the question. Then we substitute the values into the equation to get a quantity for what? Mike. So QDX was 3, 3, 721.01476 minus 260.6819. The variable here was px, and the px was given as 15. So you fix the 15 here. Okay. Minus, I'm picking the equation from the top. So 4.992784.128 times that side. The variable there was m, which was income. So the income was given as 10,000 plus 7 points. So you can try and cross check it with the equation at the top. It's the same equation I'm bringing here. I'm just substituting the values into the equation. So 7.20468044.3. Now the variable here was advert, and advert was given as 1,000 minus 4465 point 5353 times, this is 08 times, the item here was PS, so PS is 2 plus 112.6920.947. I'm picking it from the side. Since I already know how I was able to form this, I'm just picking them from the side. So you notice that the same equation, the one we formed in the A part of the question, is the same equation I brought to the side. I'm just substituting the values that were given into the equation to get what? Quantity. So now when you punch everything using the calculator, you are going to get minus 190 minus 19026 0.14416. So this is what we are going to get when you punch everything into the calculator. So you notice that we are getting a negative quantity. It happens. So to determine how many units. So this was the unit. So that's the D part of the question. So we are moving to the E part of the question. So with the E part of the question, comment on the assertion that Mike's Pizza is an inferior good. So Mike's Pizza. Comment on the assertion that Mike's Pizza is an inferior good. Now, we've been asked to comment on the assertion that Mike's Pizza is what? An inferior good. What we do is, we have inferior good and we have normal good as well. Now, with inferior good and normal good, they both fall under what we call income. Although Mike's Pizza is being mentioned, we don't use Mike's Pizza to determine whether the good is a normal good or an inferior good. The question stated that comment on the assertion that Mike's Pizza is an inferior good. So they are trying to say that Mike's Pizza is an inferior good, but take note, in determining inferior good or normal good, we use income. We use this income. Now with income, in the question, the variable for income was given as n. So I would have to come and check the coefficient of this n, the coefficient of this m in the equation. If I check this coefficient and it's negative, it means it's an inferior good. If I check and it's positive, it means it's a normal good. So that's how we do it. So we'll come and look for this variable in the equation. So you can say it here. This is the n. So the coefficient is what? It's negative. So they are asking you to comment on the assertion that Mike's Pizza is what? An inferior good. So you can notice that the coefficient of m is negative. This is it. So if the coefficient is negative, it ascertains that what? Therefore, it's what? An inferior good. So therefore, Mike's Pizza. Mike's Pizza is an inferior good. It's an inferior good because it has a negative because it has a negative coefficient of income. I'm coming. Let me. Since my part is disturbing, so I'm coming. Okay, so let me continue. Okay, so Mike's Pizza is an inferior good because it has a negative coefficient of what? Income. So that's all for the E part of the question. So the F part of the question. With the F part, how does chicken pizza relate to Coca-Cola? So the app they gave chicken pizza, chicken pizza, and what? Coca-Cola. But when you check the question, there's nothing like chicken pizza and Coca-Cola. So I'm sure this was because Coca-Cola is what? A drink. Are you okay? And in the question they gave us what? Sprite. Sprite, sorry. So let's do it this way. So with a chicken pizza, you in place of the chicken pizza, we'll use Mike's Pizza because that was the actual question. So Mike's Pizza. I'm sure there was a mistake with this. Mike's Pizza. Then in place of the Coca-Cola, we will use Sprite. So we are rather going to do the analysis based on what? Mike's Sprite, Mike's Pizza, and what? Sprite. So this is supposed to be the correct question, but not this one. So how does Mike's Pizza? So the correct one is how does Mike's Pizza relate to what? Sprite. So when you check the question from the side, so how does Mike's Pizza relate with what? Sprite. So you check px. This is what? Px. So you check the coefficient as what? Negative. Are you okay? So whenever the question is talking about relationship, relate is the same as what? Relationship. Let me do it here. Relate or relationship. They made mention of Sprite. That's why you are using Sprite. So relate. So relate, we have substitute good. And we have complementary good. If the coefficient of Sprite is negative, then it's a complementary good. If it's positive, then it's a substitute good. That's how we do it. So how does Mike's Pizza relate with what? Sprite. So Mike's Pizza is the actual product in question. So how does Mike's Pizza relate with what? How does Mike's Pizza relate with Sprite? Whenever they use relate, that's what we call a relationship. So we use substitute and complement. So you focus on the second item's coefficient. So the second item here is Sprite. So you focus on the Sprite what? Coefficient. So you come to the question. So there is coefficient. Let's look for in the question they stated that PS denotes what? Sprite. So the Sprite, the PS, we check the coefficient is what? Negative. So it means it's what? A complementary good. So now we've identified it to be what? So how does Mike's Pizza relate with? So that's what? A complementary good. So the answer. So the relationship between Mike's Pizza and Sprite is what? A complementary good. Because Sprite has what? A negative coefficient. So I'll move on to the gem part of the question. So with the gem, from the question side, gem is how does chicken pizza relate to this pizza? So they made mention of chicken pizza. And chicken pizza and what? This pizza. Now, how does chicken pizza relate with this pizza? So with this particular question too, you would correct it and do it Mike's Pizza. Mike's Pizza. Mike's Pizza and Max Pizza. Because those are the names being used in the question. Because we don't have anything like chicken pizza and this pizza in the question, but those are the correct ones in the question. So Mike's Pizza and Max Pizza. So we are correcting the question. So the question, so this should have been the question. This is the correct one. How does Mike's Pizza relate with what? Max what? Pizza. So this side too, I told you that this side too, this should have been the question. So this is the correct question here, but not the first one. Okay. So how does Mike's Pizza relate with what? Max Pizza. You notice that in the question, Mike's Pizza was the what? Mike's Pizza was the actual product. You can see it from here. QDX is what? Mike's Pizza. So it means any other price apart from Mike's Pizza's price is what? A related product. So we'll come and look for Max Pizza. Which variable was used for Max Pizza? Let's check here. Max Pizza is what? PM. So we'll come and look for the variable PM. So this is PM. Then we look for the coefficient. So this is the coefficient. Coefficient of PM is 1, which is positive. So like I said earlier on, if the coefficient of, so we will come and look for the coefficient of Max Pizza. This one, coefficient. Oh, my pad is disturbing. Let me just explain it. I don't know why my distance is disturbing. So you have to come and check the coefficient of this. If the coefficient of Max Pizza, they use this variable for it, PM. So we have to come and check. Oh God, this one touch this thing disturbing like that. If the coefficient of Max Pizza, they used PM. If the coefficient of Max Pizza, if it's positive, then it's a substitute good. If it's negative, then it's a complementary good. So you would have to go and look for this PM in the question. So this is PM. The coefficient of PM is positive. So PM is what? A normal good. So Max, sorry. PM, relationship, we do a substitute and complementary. So we have to come and look for this variable in the question, PM. So this is PM. The coefficient, if it's positive, then it's a substitute good. But if it's negative, then it's what? A complementary good. So we could say from this side we were positive. And the question is saying that how does chicken pizza relate to this pizza? So the relationship that exists between chicken pizza and this pizza is what? The relationship that exists between, in the question there was nothing like chicken pizza and this pizza, so I've corrected it. So this is the correct one. So the relationship that exists between Mike's Pizza and Max Pizza is what? A substitute good. So the answer is a substitute good. Because the coefficient of Max Pizza is what? Positive. That's why we picked it to be what? A substitute good. That was the gym part of the question. Now with the each part of the question. at a level of significance of 0.05, determine which of the variables are statistically what significant. They didn't give us any t tab or any t critical, so it means in the question we are going to use the concept of p-values and compare it against the level of significance. If your p-value is greater than your level of significance, if your p-value, so the h, so we are calculating for, so we are finding the statistical significance of variable. Oh, today my part is really disturbing. I hope you guys would forgive me. It's really giving me problems. Okay, so let me start. The age question. So we have been asked to find the statistical significance of what the variables. So the age, we are going to compare p-values against level of significance, which is alpha. It was given as 5%, 0.05. If your p-value is greater than your level of significance, it means the variable is not statistically significant. But if your p-value is less than it, then so let me draw it here. Rules. If your p-value, the first one, if your p-value is greater than your level of significance, which is alpha, so the decision to be taken is not statistically significant. So the decision to be taken is not statistically significant. Now, the second decision is if your p-value is less than your level of significance, then it's statistically significant. So these are the rules of the game. With the H part, these are the rules we are going to use. So let's start. So I have variables column here. Variables column. So the variables in the question, we're given px. We don't use the constant, we don't use the beta naught. We use the independent variable. So px. I have m. I have advert. I have ps. I have pn. The next column is the p-values column. So p-values. So the p-value. So p-value for px. P-value for px is 0.1088. 0.1088. I'm picking them from the question this side. So p-value for advert is, so p-value for income is 0.0001. P-value for advert is 0.0000. P-value for PS is 0.03, 0.03. 0.079. P-value for Pn is this 0.6605. So this is the p-value column. So now I can go to a full screen and explain it. So okay. So the next column is the level of significance, which is alpha. This is the alpha. So that's 0.05. Okay. So this is 0.05. This one is 0.05. The level of significance is 5%. So I'll fill it in the whole of this column. So this is 0.05. 0.05. This is also 0.05. So we can now do the comparison. So this side is our decision rule. So now, if this p-value is greater than this, it means it's not significant. If it's less than the 0.05, then it means it's what? Significant. So the first one, this is bigger than this. So not significant or not statistically significant. This is not significant. This is less than this. So it's statistically significant. Then the third one, this is less than this. So statistically significant. The next one, this number, this is 0.03, 0.05. This number is less than this. So it's also statistically significant. Then the last one, this is greater than this, so not significant. Okay, so that is what we have now. So once you are done with this, you are supposed to make a conclusion. Okay. So with the conclusion, we were given 0.05, which is 5% level of significance. So now with significance levels, we can be given 10%, 1%, or 5%. They gave us 5%. So total percentage is 100. So 5% minus 100 gives us what? 95%. If you are given 10%, 10% minus 100 gives you what? 90%. If you are given 1%, 1% minus 100% gives you 99%. So here we're given 5%. So 5 minus 100 gives us 95. So at 95% confidence level, all the independent variables are are statistically let me clean this are statistically significant. Today my part is really disturbing. Sorry about that. At 95% confidence level, all the independent variables are statistically significant. So you name the variables that happen to be significant. So M was significant from here. This is N, significant. Advert was significant. ADV. PS was also significant. PS. With the exception of with the exception of with the exception of PX and PM, which are which are not significant. So that's how we solve the each part of the question. So we move on to the I part of the question. I. So the I part comments on the overall significance of the model. So overall significance of the model. So with the overall significance of the model, we'll come to the question. We use these two things here to do it from the ANOVA table. So F value, the F value, the F value is oh shit. Oh, let me clean it. So the F value, this is it. 31 319 4.68792, and the other F, the significance F2 was 0.0000. If this is greater than this one, that means the overall model is statistically significant. But if this one is less than this, that means the overall model is not statistically significant. So from what we are seeing here, this is greater than this. So it means the overall model is statistically significant. The overall model is statistically significant. Then you move to the G part of the question. So the G part of the question. The G, where is it? This is the G. Derive the demand curve for Mike's Pizza. Demand curve. Demand curve for Mike's Pizza. So we've been asked to derive the demand curve for Mike's Pizza. So we'll still use the same estimated demand equation, what we solved for. That's one. We'll use the same demand equation, but we've been asked to find demand curve. It shows the negative relationship, negative or an inverse relationship between price and quantity demanded of that same product. So once we pick the estimated demand equation, this particular one, we would maintain Px, but with the other variables, we will substitute their numbers into it. So let me see if I can copy this thing. Let me see if I can copy this. It's not able to copy. Let me just go and write it there. I thought it could copy. So what we are going to do is we would rewrite that equation. So the equation was q dx was equal to 3, since we couldn't copy, so we are rewriting everything. 33721.01476 minus 260.6819px minus 4.99278412.8n plus, I'm rewriting the equation again, plus 7.204680443 advert minus 4463.535308 ps plus 112.6920.947 p.m. So this was the regression model or regression equation, the one we solved. Now they said we should find demand curve. Now in the question they gave M to be what? M to be 10,000. They gave advert adverts to be 1000. They gave PS to be 2. They gave PM to be 25. Now, with demand curve, it shows a relationship between quantity demanded of a good and price of that same good. So there is a negative or an inverse relationship, either negative or inverse relationship. Yes. So this is the concept. This is the concept behind. This is the concept behind demand curve, relationship between QDX and PX. So with this estimated demand equation we have here, we will use the same thing, but we would maintain the PX because of the definition. I'll maintain relationship between PX and what QDX. So with the other variables like M, advert, PX, PN, I'll substitute their values into it. So I have QDX here. This is 33721.01476 minus 260.66819.889 px. Remember that we are finding demand curve, so we are maintaining the px. Okay, minus 4.992784.128 m, and the m was given as what? 10,000. So 1, 2, 3, 4. There's it. Then plus 7.20204 68044.3. Advert was given as 100. Sorry, 1000. Okay. Minus 4 point, sorry, 44 6 5.535308. px was given as 2. px was given as 2. px is 2 plus 112.692094.7. Then pm in the question was 25. Take note, we maintain this QDX and also maintain PA because of the definition of the demand curve. We want the relationship. So now we will sum all the numbers together. So when we sum everything up, we are going to get minus 15,115.14416 minus 260. What we left out, that's one. We bring it down, minus 260.6819.889 px. So this becomes our demand curve. That's our demand curve. So let's check the question. Okay, so sketch the demand curve for Mike's Pizza. We've done it. That's key. So now, no, that's D. Derive the demand curve for Mike's Pizza. We've done it. The key, they said we should sketch it. Okay. So in sketching it, I have this. This is QDX is equal to, I have minus 1,511.5.14416 minus 260.68198889. This is PX. So the same format. So if you want QDX, you make PX 0. If you want PX, you make QDX 0. So when PX is equal to 0, so I have QDX is equal to minus 1,511.5.14416 minus 260.198 another 89 where PX is 0. Oh shit. Man, this thing is really disturbing today. So 260.68198889. Then PX, we are saying we are doing it what? 0. So it means QDX is going to be minus 1,511.5.14416. So this is the quantity. So now, when the part is really disturbing today. Oh God. So when QoS is also equal to 0, so 0 is equal to minus 1,511.5.14416 minus 260.681989 PX. So since we are finding PX, we move it to the left hand side, becoming positive. So I have 260.681989 PX is equal to minus 1,511.5.14416. Since I'm finding PX, I'll divide both sides by the coefficient of PX, which is 260.681989. 260.681989. So now PX is equal to minus 1,511.14416 divided by 260.681989 gives us PX is equal to minus 1, sorry, It's minus 57. Hmm? 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 Minus 57.9830 minus 57.98307.825. Which is approximately minus 57.98. So this is the price, and this is the quantity. So we've been asked to sketch. So I have this. This is quantity. This is price. So we have negative quantity. So we had a negative quantity to be minus was minus 1 point. So minus 15115.14. Let me do 14. And we had price to be minus 57.98. So where they are joined, we have to get a curve there. So we have this. So that's what we're asked to do. We're asked to sketch the demand curve. So the next one is the I part of the question. Calculate and interpret on price elasticity. So we've been asked to calculate on price elasticity. You guys should please forgive me. Today my part is a bit disturbing. So on price elasticity, we have EPX. We will find the derivative of QS with respect to PX times PX over QS. With respect to PX over QS. So PX was given in the question as 15. Now the QS we solved from the beginning of the question was minus 19026.14. That was what we solved in the question. Now, with this side, if you want to find for this side, you look for the estimated demand. So you are finding the derivative of QS with respect to what PX. So you come and look for, or simply, let's do it this way. You come to this side, the question. Which variable are we dealing with? They said home price elasticity. So you are dealing with what? PX. So you come to the table, this is PX. This is the coefficient. So the whole of this side, you will fix the coefficient there. So the coefficient is what? Minus 260 points. So like this. So minus 260.68 times the PX was given in the question as 15. Then QS, what we solved was minus 19026.14. 0.14. So our answer. So if we punch it to the calculator, we are going to get 0.21. 0.21. 0.21. So if it's less than 1, inelastic. Greater than 1, elastic. Equal to 1, unitary. So this is less than 1. So it's inelastic. So that's I. So we move to uh, so that this is not I, this is rather L. Sorry, it's L, not I. Since we made a wrong number, it's L, not I. It's L. So the next question, it's M. So with the M part of the question, this is M. So with the M, based on the answer in H above, comment on the success of failure of a discount sale by the firm designed to increase revenue. No. Now, whenever there's increase in revenue, it depends on the price you are selling. Yeah, it depends on the price you are like. Assuming you are selling a particular product, let's say yam, the price you are giving out for that particular product will show the income or the earnings you are going to get. So revenue is dependent on what? Price. And in the question, the actual price was what? PX. So they are saying that based on the answer in each above, comment on the success or failure of a discount sale by the firm designed to increase revenue. So before you be able to increase revenue, it depends on your price. If you charge a higher price, you get a higher revenue or a higher income. If you charge a lower price, you get a lower income. So with the M, so with the M, we have various prices in the question, but we use the actual price in the question. The actual price in the question was PX. So this is the price we are going to use to solve the question. So we'll have to come and check. Instead, based on the answer in each, so let's go to the each part and let's go and check for PX. So this is the each part of the question. So PX, we had price to be what? Not significant. So PX in each part of the question was found to be not significant. As based on the answer in each above, comment on the success or failure of a discount sale by the firm designed to increase revenue. And I indicated that our focus is on what? PX, because that is that we have PM as well. But the actual price of the product is what? PX. So it's PX we use to answer the M part of the question. So from the H, P was found to be what? Not significant. So they are asking, comment on the success or failure of a discount sale by the firm. Since we are PX happens to be not significant, it means that it won't or we won't be able to increase revenue. Assuming PX had been significant, it means we'll be able to increase revenue. So you put down a statement. So success so let me rather do it in a short way. So since What is the cursor not coming? So since price since price remember price just the px, since price not is not statistically since price is not statistically significant. Remember p, the coefficient was 0.1, the p value was 0.1088. a discount a discount sales aimed at oh, oh god, really my touchpad is really worrying. Oh god. So since price is not statistically significant, p is equal to 0.1088. A discount sales aimed at increasing revenue aimed at increasing aimed at increasing revenue revenue may fail. Since price was found to be not significant, it means that the discount sale which is aimed at increasing revenue may fail. That's the end part of the question. I hope you guys will manage it from because my lesson is really disturbing today. So what then do we do? So I would recommend the firm to choose advertising to increase its revenue since its firm is statistically significant. When you check the advert, you notice the advert was 0.00000 from this side. So advert is the highest significance value there. So I would rather recommend the firm to choose advertising to increase its what? Sales. Also to increase its revenue. That would be the best option. So let me go to the end part of the question. So the end. Calculate the cost price and income elasticity. So cost price. So cost price, we have the formula. Derivative of QoS. In the question, the related price in the question was given as PM. So times PM over what? QoS. So they gave us PM in the question. This is it. PM is 25. So PM is 25. And QoS, we solved it ourselves in the question. It was minus 19026.14. So I told you with that side, you have to pick the coefficient of PM. So this is PM. So the coefficient is what? 112. So I have 112 points. Let me do what? 69 times 25 over minus 19026.14. So when I do this, our answer is going to be minus 0.15. Cross price, if it's negative, it's complementary. If it's positive, then it's a substitute good. So this is a complementary good. Cross price. At the same time, also ask to find for income elasticity. So with the income elasticity, we have this. Derivative of QoS. Income, they gave us income variable to be what? M. Oh. They give us income, so it's derivative of QoS over derivative. Oh shit, God. I'm sorry for today. My destiny is really disturbing. But I think we've tried to be able to get to this point. So derivative of QoS. Oh, good. Let's clear it. So derivative of QoS over derivative income, the variable was M. So this is M over what? QoS. So they gave us M in the question. M in the question was 10,000. Now the QoS we solved from the question was minus 19026.14. Now with this side, as I said earlier on, we pick them from the question. This particular side, we pick them from the coefficient of n. So you come to the question, this is the n, look at the coefficient, minus 4 points. So the whole of this is minus 4.992 times m was 10,000 divided by minus 19026.14. So the answer, so when you point this on the calculator, we are going to get 2.62. If it's negative, inferior good. If it's positive, it's a normal good. So this is a normal good. Yes. So that's how we solve this particular question. Sorry about the issues with the marker. I was having a small issue. I don't know why. Yes. So that's how we solve this particular question.